Hey guys, welcome back to my channel. In this video, we will be talking about parse tree, ambiguous grammar, and unambiguous grammar. So we'll be having some examples too about these topics. So let us first discuss about parse tree. What is a parse tree? Parse tree is a pictorial representation of derivation. The root of the parse tree is the start symbol. So here we have assign. Assign is our start symbol, and every internal node is labeled with a non-terminal symbol. So here we have id and here we have an expression. So each and every node is labeled with a non-terminal symbol. So we have this non-terminal symbol. Here we have equal into, okay, and every leaf node is labeled with a terminal or non-terminal symbol. So here this is a leaf, this is another leaf. So in each of the leaves it is labeled with a terminal or a non-terminal symbol. So this is a example for parse tree for the equation a is equal to b into c plus d. So we are considering assign as our start symbol and id expression. So assign is derived into id, and id is equal to expression, and expression is derived into id into expression, and id is derived into b, expression is derived into uh, brackets expression, and expression is derived into id plus expression, and so on. So this is the parse tree for a is equal to b into c plus d. It is in the order of leftmost derivation. Now let us see again see the construction of a parse tree. So here we have assign id equal expression, then assign id equal expression, and after id we have a. Because we are using leftmost derivation, we will be completing the leftmost part, and then only we will be going to the right part. So as the leftmost part is complete here, so we'll be moving to the rightmost part, and this will be considered as the endmost part, and we will be continuing till we complete the tree. Now when we create a parse tree, there are two grammars which we have to learn, which are ambiguous grammar and unambiguous grammar. So what is a ambiguous grammar? A grammar that generates a sentential form for which there are two or more distinct parse trees, or two or more leftmost derivations, or two or more rightmost derivations, is called ambiguous grammar. So let us consider this. An ambiguous grammar for a simple assignment statement. So these are our rules, which are called production rules. Assign implies id is equal to expression. Id implies a or b or c or d. Expression implies expression plus expression, or expression minus expression, or expression, or id. So what we have to create from this grammar is a is equal to b plus c into d. So we have two distinct ways of leftmost derivation. Assign implies id is equal to expression, a is equal to expression, and this expression can be converted into expression plus expression, or expression into expression. So here an ambiguity rises. So what should we do in these cases? We are going to look about this in unambiguous grammar. So in unambiguous grammar, there is no ambiguity. So we will be converting this ambiguous grammar into unambiguous grammar by considering the ambiguity rules. So there are two rules, which are operator precedence and associativity, which we need to check so that our parse tree becomes correct or we get a unique parse tree. So what is operator precedence? Like in mathematics, in here also we have a precedence of the operators. So the it is in the decreasing order. So minus comes the first, then we have this arrow, then we have this multiplication and division, then we have plus and minus. So these are the operators in decreasing order. Now we have associativity. Associativity means that in which order should we consider the operators. So here we have this arrow. It is right associative. That means we should look it from left to right. Sorry, we should look it from right to left. So this is our right, and we should be going in this order. But in the case of binary operators or the operators which needs two operands, they are left associative. The left associative operators are addition, subtraction, multiplication, and division. So here we have got an example: a minus b minus c. We can't read this from the right to left. We can't read it like c minus b minus a. We can only read this equation, read the statement from left to right. So that is why we call this left associative. So this can be read as a minus b minus c. Similarly, we have a is equal to b plus d, and this can be b plus d cannot be read from left to right. And this equal to sign is right associative. That means it can be read from right to left. So it can be read from right to left. Now, considering the ambiguity rules, we'll be checking our grammar again. So here we have the same grammar, but except that we have changed some part of it. So here we have the starting rule, which is assign implies id is equal to expression, and we have id is implies a or b or c or d, and here we have got some changes. So we have changed this expression into expression plus terms or term. Here we have got a new uh, id which is called term. So this term factor has completely changed the grammar from ambiguous to unambiguous grammar. Similarly, we can use this arrow and minus operators in this another example. So considering the same example and using the unambiguous rules, we can complete this and we'll be getting a unique parse tree. So in similar manner, let us consider an example: a is equal to b plus c plus d. As plus or the addition operator is less left associative, we can show the parse tree in this format. So this is the unique parse tree because we are considering the associative rule in this parse tree. So this is all for today's video. I'll be coming up with new videos every week. Thank you for watching.